Okay, so for this last video for this algebra unit, you're going to actually need two papers. So you'll need the notes for writing equations of special segments. Looks like this page. And then you're also going to need the first worksheet. We're going to do a couple of examples together. And it's writing equations of special segments of a triangle. And it's the first worksheet, not the one that says number 2 at the top. That is the second worksheet that you will probably want to do after you cover this material. And we're not going to do all of these together. We're just going to do a couple as more examples because this is a pretty, it's not pretty hard, but it's the hardest part of this unit. All right, so let's get started with the notes first, and then we will do some examples. So remember the special segments. So we went over these when we were talking about the different points of congruency in a triangle, like circumcenter, incenter, centroid, those things. So if you remember, a median is the line segment and this is not the official definition that you learned, but I'm reviewing it in a simpler way. So it's the line segment that connects a vertex of a triangle to a midpoint. So the median, if we were to draw a triangle up here, is going to go from the vertex up here to the midpoint down here, so that would be the median. Okay, and the altitude, if you remember, is the line segment that starts at the vertex, one of the vertices, and is, remember, perpendicular to the opposite side of the triangle. So in our triangle up here, that would be starting at the vertex and it would be going perpendicular to the opposite side. So it really has nothing to do with the midpoint. It's just wherever it becomes perpendicular, and that has to do with the slopes when we're talking about algebra. That's why in the past videos you learned how to tell if slopes were parallel or perpendicular. Just as a quick review, perpendicular slopes are opposite reciprocals. In other words, if we have a slope of 5/4, this perpendicular slope, which is represented with slope and then this is a little perpendicular sign, would be flip the fraction and the sign. So that would be the perpendicular slope. We're going to need that in a minute. Okay, and the last thing that we'll need is perpendicular bisector. And this is a line that passes through the midpoint and is perpendicular to the side of a triangle. So it has nothing to do with the opposite vertex. Instead, it is, I'm going to do this one in red for you, James. The perpendicular bisector is the one that goes through the midpoint, so it's going to start at the same point the median ends, and it's simply perpendicular to this side, so it's going to look something like that. Okay, so those are 3 special segments, and I put them all in one triangle here for you, so you can kind of see how they all differ from each other. None of them are the same in this triangle. There is the case if this was an equilateral triangle where these 3 would actually overlap and be the same, but that's not the case here. Okay, so let's do a sample example on how we're going to connect this to everything you just learned and reviewed from algebra. Oops, sorry, gotta make this straight. Okay, so the first thing we're going to do is we're going to graph a triangle, And that is just going back to whether or not you can graph coordinate points. So we're going to graph the triangle DEF with D at 2, 5. So you can go ahead and do this with me. 2, 5. E is at 8, 3. And F is at 2, 1. So it's going to look like this. After I connect them, I'll label them D, E, F. Okay, so there's our triangle. So now we're going to write equations for a couple of the different special segments we have here of this triangle. So the first thing we want is the median from D. And if you remember from what we just talked about up there, the median is a line segment that connects a vertex, in this case they want D, to the midpoint of the opposite side. So in other words, somehow we're going to find the midpoint over here, and we want the line. Now obviously a median is a line segment because it has an end point this side and this side, but we're actually going to just give the algebraic equation because there is no such thing as an algebraic equation for a line segment. It's going to be a line, and part of that line, this part of it, will be the segment. So the median is actually on this line, but we want the equation of this line preferably in y equals mx plus b form. So let's go ahead and do that. So the first thing you're going to need to do to find the median is find the midpoint. So first step is find midpoint of opposite side, and that is FE. So we need to find the midpoint of FE. If you remember the midpoint formula, it's simply averaging the two coordinates of your segment. So if we were to average EF, we're going to get 8 plus 2 divided by 2 is 5, and then 3 plus 1 is 4 divided by 2 is 2. So here's that point right there, and if you check it on your graph, if you were to graph 5, 2, I drew it about in the right place. That's 5, 2. Okay, so that's one point. Now look here, we have the coordinates of D, and we have the midpoint coordinates. If you remember, you only need two coordinates, 2 points, in order to write a line. So the next step would be find slope between D and midpoint. So we're finding the slope between these two. We have D up here, and we have the coordinates of the midpoint. So I'm going to just set up my slope equation. So we're going to do 5 minus 2 is 3, over 2 minus 5 is negative 3. So overall my slope is negative 1. Okay, so now we have slope, and then 3 would just be right equation using one coordinate. I'm just going to go ahead and use D since it's up here and written for me, but you absolutely could use this one, it doesn't matter. And if we have slope and a coordinate or a point, we're going to put it to start with in point slope form, which I'll help you recall. It was just in the notes the other day, y minus y1 equals m x minus x1. So really, after we found the midpoint up here, we're just going back to algebra and writing equations of lines. So I have y minus 5 equals, I just found my slope, negative 1 x minus 2. And then I just need to convert that to y equals mx plus b form, so I'm going to distribute here. I get y minus 5 equals negative x plus 2, and then y equals negative x plus 7. If you want to check yourself, go back to your graph and you can check yourself. Does it look like I have a slope of negative 1? Well, yes it does. If we know if we put a little guy up here, he'd be walking downwards, and it's a pretty medium grade. It's not very, very steep, and it's not very flat. So it's about -1. And then it looks like my y-intercept would be about 7. So if I count that, 1, 2, 3, 4, 5, 6, 7, yep, it's about there. So that would be the coordinate, that would be the equation that my median was on. All right, let's do the equation that would contain the altitude to side DE. So in other words, if we want the altitude to this side, it would be as if we flipped our paper around and we had the height of the triangle from F going down to DE. So I think that's going to look something like this, because we know it needs to be perpendicular to side DE. So that would be the altitude. If you flipped that upside down, let's see if I can do that. Flip that upside down, do you see how that contains the altitude or the height to DE? Now again, the altitude is a segment, but it does fall on the line that I just sketched in here. So for altitude, you need a couple of different things than a median. So median, we needed the midpoint, and then we had to find the slope from the midpoint to the opposite vertex. Here, we are going to need to find the equation of the line, but it needs to be perpendicular to DE. So the first thing we're going to do is find perpendicular slope to DE. Now, in order to find what the slope that's perpendicular is, we first have to find what the slope of DE is. So if I look up at my coordinates up at the top, my coordinates for D and E are 2, 5, and 8, 3. So first let me find the slope there. So I'll do 3 minus 5 is -2. 8 minus 2 is 6. So that looks like a slope of -1/3. The opposite reciprocal slope, or the perpendicular slope, would be 3/1, positive 3/1, or just 3. So that's just review from last time when you were doing parallel and perpendicular slopes. Okay, so we know the slope of this altitude line is 3, and that makes sense because if we put a little guy down here on the left, he would be walking up a pretty steep slope, and it's positive. The second thing for writing altitudes is simply to write the equation using perpendicular slope that you just found, literally this one, and coordinates of opposite vertex. In this case, that would be F. So if we have point and the slope of this line, we're going to put it again in point slope form, excuse me. So I'm going to do y minus, the coordinates of F are 2, 1. So I'll do y minus 1. I'm just using the coordinates that are listed up here. You can't see it because I've moved the paper down, but look at yours and it tells you what the coordinates of F are. I'm using them. So y minus 1, which is the y coordinate of F, equals 3, the perpendicular slope I just found, times x minus 2. I'll just distribute and change that to y equals mx plus b form, but this is acceptable as long as you don't have to change it. So I'll distribute y minus 1 equals 3x minus 6, y equals 3x minus 5. And that would be the equation of this line that contains the segment of the altitude to DE. Alright, last but not least, we're going to do the perpendicular bisector of EF. And just so it's a little bit easier for you to see, this has nothing to do with D. It has everything to do with the side EF. And all you're going to do there is, you know that from the top we just went over, perpendicular bisector goes through the midpoint, and lucky for us, up here we've already found the midpoint of EF, and it is perpendicular to that side. So in this case, it's probably going to look something like this. I'm doing it in greens just so you can see it easier. So it's going to pass through the midpoint, and it's also going to be perpendicular. So the steps to finding the perpendicular bisector, if we hadn't already found it up here, you'd first have to find midpoint of the side. In this case, we're talking about EF, but we've already done that, and we found that it was 5, 2 by averaging the x and y coordinates up here. Okay, then you would have to find the perpendicular slope. Again, this notation just means perpendicular slope, and to do that, we're going to have to find first the slope of EF. We have the coordinates for that. They're up at the top. I can't show you because they're already listed, but essentially you're just finding the slope, and that would be 1 minus 3 over 2 minus 8, which is negative 2 over negative 6, or 1/3. Then the perpendicular slope would be 3. Hopefully that makes sense. No, it would be negative 3. I'm sorry, James. Negative 3, because you have to flip. It's opposite reciprocal. Flip and change the sign. Negative 3. I just looked at my green line and looked, oh, that's not a positive slope. It's definitely negative, so it's negative 3. Now I have the midpoint, the point it's passing through up here, and I also have my slope. Point and slope means we should put it in point slope form. Over and over again, you're going to use point slope form. So I'll do y minus 2 equals the slope I just found for my perpendicular bisector, negative 3 x minus 5. Again, I'll just distribute and change it to y equals mx plus b form. You do not have to do that, but it's kind of good practice, and I think it's the easiest form to work in. So negative 3x plus 17. And there would be the equation of this green line that my perpendicular bisector is. Just to refresh your memory, perpendicular bisectors are indeed lines. They are not just line segments. So medians and altitudes are line segments. Perpendicular bisectors are actual lines. They have no endpoints. They just pass through this point. So there's no special endpoint that's a vertex up here. It just goes through some part of the other side. All right. So that's it for the notes, but I wanted to go through a little bit of this first worksheet with you because I think again, this is the most challenging part of this unit, and I know you're away. So, all right. So what is needed to write an equation of a line? Essentially, there's a couple of options for you. You can have 2 points, and then you would have to find the slope from them. You can also have 1 point and slope. So on this one, must find slope. Okay, so this is obviously the easier one if you have a point and a slope already given to you, or you can find the perpendicular slope or something like that, then that's the easier one. But if you're given 2 points, you can. It's just an extra step and you have to find slope. Okay, so to write the equation of a median, remember a median goes from the vertex of a triangle that we assume you've already been given to graph. So you would have to find the midpoint of the opposite side, like we just did in the example number 1 from the notes, and then the slope from vertex to the midpoint you just found up here. and then you have a point, the midpoint, and you have a slope. So according to number 1, we needed a point and a slope to write the line. That's what we have for median. Okay, to write an altitude, remember an altitude is the one that passes from the vertex of a triangle to the perpendicular slope to the other side. So it goes through the altitude. And this is a segment, but it lies on a line. So you need perpendicular slope. That's just the shorthand or representation of perpendicular slope of opposite side, and you need you need the vertex coordinates. So in other words, you'd have these coordinates, and then you'd have to find the slope perpendicular to this opposite side. Okay, and last but not least, if we want to find the perpendicular bisector, all you have to do is you need midpoint of a side, and then you need, perpendicular slope to that same side. So in other words, if we were doing the perpendicular bisector to this side, we would need to find the midpoint, and then we would have to find the slope perpendicular to that side. So this would be perpendicular bisector. And again, there you have a slope, and the midpoint serves as your point, so it satisfies this 1 point and 1 slope needed in order to find the equation. Okay, we're going to flip to the back. So this numbers 5 through 7 are almost exactly like what we just did on this page with the examples, but it's walking you through in nice easy steps the same thing we just did. So if you follow the steps, that will help you find the equation. All right. Last but not least, we're going to do numbers 1 through 9 on the back to kind of tie it all together and hopefully help you. Okay, so first things first, I'm going to graph these points and connect them because they're going to form a triangle. Any 3 points will form a triangle. So A is at 0, 0, or the origin. That will be rather nice because it'll make some calculations pretty easy in a minute. B is at 12, 6. So give me just a second to count here. 4, 8, 12, 3, 6. Okay. There's 12, 6. And then C is at 18, 0. So 12, 13, 14, 15, 16, 17, 18. So, boy, they made this triangle nice and... actually, this is good because then we can review what the slope of a flat line is. Alright, so hopefully you can see my triangle here. I'll label the points in just a second. There's a blue line across the x-axis, you just can't see it. Here's A, up here is B, and this is C. So here we have our triangle. Just as a quick refresher, this slope is totally flat from A to C. That is a slope of 0, and a straight up and down slope. Remember, you'd have to get some sort of cliff climbing equipment if you were to put a little man here. Otherwise, he would be unable to climb, so it's undefined slope. All right. First things first, we're going to find the midpoint of AB. That's all it's asking us to do. So in other words, we're going to find wherever the midpoint is, somewhere over here of this side of the triangle. For that, you're just averaging the 2 coordinates, so I'll walk you through that. You add them up, divide by 2 for 2 numbers, so 0 plus 12 over 2, and then 0 plus 6 over 2. That is going to give you a midpoint of 6, 3. And if we were to graph that, 6, 3, okay, so I didn't draw my line very well. I should have used a ruler, but it's about there. Okay, so then we find the slope of AB. To find the slope, remember you're going to use the slope equation. So I'll subtract y1 minus y2. That's 6 minus 0, or 6. And then x1 minus x2, or 12 minus 0 is 12. That gives me a slope of 1/2. And you can see if you put a little guy over here, he's walking up like a moderately steep slope. It's not quite as great as a slope of 1, which would be up 1 over 1. Up 1 over 1. So it's a little bit less than that. Alright, and then write the equation of a line perpendicular to line segment AB, to this side, that passes through its midpoint. So I'm going to sketch this in green. So it's going to pass through the midpoint we just found, and it's perpendicular to that side. So it's going to look something like that. Perpendicular to that side, passes through the midpoint. Well, we know already we have a point, the midpoint, on this line, and we know the slope of AB. The perpendicular slope to AB is going to be the opposite reciprocal of its slope, so -2. If we want to write the equation of the line, we have a point, we have a slope. I'm just going to put it in point-slope form, and I won't even bother converting it. So y minus 3 equals -2x minus 6. That's a perfectly acceptable answer because it's in one of the 3 forms of a line. Graph this line on the same plane that you graphed your triangle. Oh, well, I sketched it, but we can graph it for sure. For that, you'd actually have to convert it. So I'm going to do that right here. Just distribute and then add to the other side. So I get y minus 3 equals -2x plus 12, and then I'll convert more, y equals -2x plus 15. Okay, so if I actually graphed this line, let's see, my y-intercept would be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, here's my y-intercept. And then I'd go down 2 over 1, 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 run. Okay, so I didn't do a very good job sketching it. I'll be more precise, James. Yours always looks better than mine anyways. So it actually looks like this. I wasn't that far off. Don't laugh. Okay. And what is this special segment of a triangle called? Well, it goes through the midpoint, which means it bisects AB, and it's perpendicular to it, so it's the perpendicular bisector. Alright, so numbers 5 through 6 is going to be similar, but it's going to be with a different side. So we're going to find the slope and midpoint of BC. Let's first find the slope. I'm just going to, again, subtract from my coordinates up here. So I'll do 0 minus 6 is -6 over 18 minus 12 is +6. So my slope is -1 for this side. That makes sense. Put a little guy up here. He's walking down 1 over 1, down 1 over 1. The midpoint would be averaging the x and y coordinates. So I have 12 plus 18 divided by 2. That's 30 divided by 2, so it's going to be 15. And then 6 plus 0 divided by 2 would be 3. Hopefully you can see where I got that from. Now we want to write the equation of the line perpendicular to BC that passes through this midpoint. First, I need to find the perpendicular slope, just the opposite reciprocal. Remember, this is -1 over 1 if we want to make it a fraction. So the opposite slope would be flip, change the sign, would be just +1. And then I'm going to put it in point slope form to begin with. Y minus 3 equals 1. X minus 15. I'm just plugging into the equation. That's perfectly acceptable, but I think in a second we're going to want to graph it. So let's just convert it really quickly. I get y equals, distribute here, x minus 15 plus 3 would be x minus 12. Oh, we don't have a graph big enough for that, so actually you wouldn't need to do this. But if we were going to graph it, I can at least graph the midpoint, which would be 15.3 right here, and then I'd have a slope of 1, so I can sketch that without actually having to plot here. All right. Okay. Find the point of intersection for the line you found in numbers 3 and 6. In other words, where would these two lines intersect? So the way we do this is we solve the system, which means at some point on our graph, these two lines are going to intersect. So on mine, it looks like they intersect about here, but we can't be sure of that unless we solve it with algebra. The way we do this, James, the easiest thing that I can teach you is to know that at the point they intersect, their y value will be the same. So at this point, it looks like their y value is going to be about -3. We're not positive on that yet, but probably about -3. Their y values will be the same. If their y values are the same, we can set their y's equal to each other. So the y of the first line equals the y of the second line at their intersection point. So up here, when I made you solve for y, and then down here, which I just scribbled out, let me rewrite that, y equals x minus 12, y is solved for us. We can actually set these two equal to each other, and then we can solve this system. That simply means that we'll have to solve the equation, in other words. So if this y is equal to this y, then this, in green, this expression has to be equal to this one only at the point they intersect. If that's confusing, we can go over it next time I meet with you. But I think you'll see in a second, there's going to be one value for x that will make this intersection point happen and their y is equal. So I'm going to set -2x plus 15, or in other words, that's what the y value is, equal to the y value over here, x minus 12. We're simply going to solve. I'm going to move my x's over. I get 3x equals 27. X equals 9. So if I check 3, 6, 9, oh, that's the x value. If I plug that back into either one of these equations, I'm just going to do this one because it's easier. I get a y equals 9 minus 12, or y equals -3. So the point of intersection then is just my x one that I just found, 9, -3. That is approximately where these two come together. Okay. And then we're going to do just number 8. I'm going to have you do number 9 on your own, which essentially, no, actually we're going to do it together, sorry. I'm trying to not make the video too long, but this is a long one. It's a long section. Okay, this one I am gonna let you do. Think about last unit what is the point at which the perpendicular bisectors of a triangle come together? So you might have to look back at your notes, but think about, is it centroid, circumcenter, in-center, or the orthocenter? Those are your options. So report back to me on that one, and then there'll be more questions like that. But I want you to remember those. Those are important. Okay, we are going to write the equation of the line. It has nothing to do with this part and everything above, but the equation of the line that is perpendicular to BC and passes through point A. So in other words, if we were to, oh, I'm sorry, it's so sloped. If we were to extend this line, we would get a perpendicular line from point A that's perpendicular to this opposite side that looks like that. So if it's from the vertex and perpendicular to the opposite side, that essentially is the altitude or height. If we were to flip our paper, that would be the height of the triangle with BC at the base if we flipped it around. Okay, so if it's perpendicular to BC, we found the slope of BC up in number 5. The slope was -1. So the perpendicular slope we actually found in 6. So we know we're going to use a slope of 1. And that looks like about up 1 over 1, up 1 over 1 in this red line. And then we want to pass through point A. Point A up at the top is 0, 0. We get y minus 0 equals 1, x minus 0. If I just simplify that, I get y equals x. I distributed there and everything. If you remember, that is the parent function of any line, and it's just up 1 over 1 starting at the origin. Pretty cool. You don't actually have to know that that's the parent function, but it's kind of something interesting that the altitude for this triangle would be the parent function. So that's it for this video. I know it's quite long, so let me know if you have any questions, and if not, good luck.